First of all, let's identify the degree so we don't miss anything. That's our first step. 4. Solutions.
4.
Which tells me that I cannot divide by x. If I divide by x, I lose a solution. But I can divide by 3, and I will, to simplify the equation. Dividing by 3 will not change the 4 solutions, but it will simplify the equation. Okay. Now, yes, I will move. I have to. And let's see what we can do next. What will you factor out? It's a binomial, it's in descending order. Yes, we have to factor out. I should have stopped and asked you what... Okay, so what do we have in parentheses when we factor out x?
X to the 3rd power minus 27.
Thank you. Sorry about that. Okay, perfect. So I know that I already have a solution from here. That is what?
X equals 1.
0.
Very good.
0.
If this is 0, then it's 0. If it's 1, 1 times whatever is not 0, but 0 times whatever is. And what is the second option? The first factor can be 0, and now the second factor can be 0, which is x cubed minus 27. Now I have to dig deep. Back to factoring. How do I factor this? It's a binomial. It's a difference. It could be the difference of squares or the difference of cubes. But it's not the difference of squares. And it is the difference of cubes. How do we factor the difference of cubes? What is the binomial? See, everything is in math built on what we studied. Everything. What do I cube to get x cubed? So remember, if this is minus, then this is minus, and this is plus. The last one is always plus.
X minus 3 and x plus...
It's a trinomial. Careful. The first term squared, the last term squared, and in the middle, just the product of the two.
So 3x.
That's it. Without that 2 from a different formula.
Give me a second to write that down again.
Say it again.
Just give me a second to write that down again.
Oh yeah, sure. So remember, it's a cubed minus b cubed, which is a minus b, and it's a squared plus ab plus b squared. And yes, if this is positive, then this is positive and this is negative. Okay, how many solutions do I have to come up with from here?
4.
3.
Yes, correct. Total of 4, but from here 3. Good. Okay, what is the next solution then? From here?
X equals 3.
Good. From here, I don't know. That's not factorable. But we know how to solve this. Negative b plus or minus b squared minus 4ac over 2a. We have 4 methods. If we cannot factor, if we cannot take square roots, completely the square never, then I can use the quadratic formula. Each equation, only one equal symbol, please. So negative 3 plus or minus, this is the square root of negative 27. The square root of negative 27, as we know, is the square root of negative 1 times the square root of 9 times the square root of 3. So this is 3i, the square root of 3, divided by 2. And we found 4 solutions. Here they are in red. 2 solutions, the third solution, and the fourth solution. A lot of work, depending on the type of polynomial and depending on factoring procedures, etc., etc. Some of them have a lot of work. Okay, question?
Well, yeah, I got a question. How do you get x squared plus 3x plus 9? Can you like review that real quick? How'd you get there?
I square this, and the product of the two. I use this formula. We discussed that formula last week when we
Just
reviewed
wanted to get a recap.
when we reviewed factoring.
Gotcha.
Yeah.
Thank you.
Thank you. And I can do more if you want to stay after class. We can look at more problems if you need to. Okay, radical equations. Okay, here it is. Let's start with, I'm going to start with number 12. The square root of 20 minus 8x equals x. It is a radical equation because it has a radical. Before we even attempt it, I would like to discuss the procedure so we understand what's happening here. So forget about the equation for a moment. These are my props, as you know. Let's suppose I have x equals 2. And if I ask you, is this already solved? You will say, yes, it's already solved. There is nothing I can do to it. Bear with me and let's say we square both sides. We will ever do that on this equation? No. Just bear with me for a moment. I just want to make a case here. Let's suppose I decide to square both sides. Before I squared, how many solutions did the equation have?
1.
One solution. So initially it had one solution, x equals 2. But after I squared, I got the equation x squared equals 4. How many solutions does this equation have? It's quadratic now.
2.
This equation will have 2 solutions. And if I want to solve it, forget about where I come from, right? If I want to solve it and I take the square root, I get x equals plus or minus 2. But I only started with x equals 2. By the process of squaring both sides, not taking the square root, by the process of squaring both sides, I obtained 2 solutions, but one of them does not fit in the original problem, which is negative 2. So the process of squaring both sides, or raising both sides to a power, not taking square roots or cube roots, but raising to a power, produces or may produce false solutions. We call them extraneous. So this is a very important note. The process of raising both sides of an equation to a power may, not necessarily, not always, but may produce what we call extraneous, false solutions. Solutions that are not correct in the original problem, and we don't care about them. How do we prevent this from happening?
We check.
Exactly. We must check. All prospect solutions in the original problem. So please remember, every time you raise both sides of an equation to a power, you must check the solutions back in the original problem. Finally, we go back to our problem. And it was so long ago, I have to copy it again. So it's 12. So we have the square root of 20 minus 8x equals x. What is the index here? I don't see any index on that root. The index is?
Square? 2? I don't know.
So if it's a square root, by convention it's 2, and we don't write it. What power will I raise both sides to? First of all, what power, again I need my prop here. When I say the cube root of x, this is x basically raised to which power?
The third. I think, or 1 over 3.
Ah, awesome. What about the square root of x? It means x to which power?
1 over 2.
Right. Because of that, which power will I raise both sides to? Because my idea is to eliminate this. I know you cannot see this, I just want to emphasize, I don't want to erase it. I want to remove that symbol on top of 20 minus 8x. And I know that the index is 2, or the power is 1/2. So which power will I raise both sides to? Which is the inverse operation, to undo the square root. Which power will undo the square root? Of course, thank you very much. Because 2 multiplied by 1/2, which is the square root, will eliminate the square root. So then, we have 20 minus 8x equals x squared. Remember, we used the procedure that may create problems. Because we raised both sides to the second power, we have to go back and check in the original problem. I know how to handle this. This was in the previous section. I move everything to one side and set it equal to 0. If factoring takes a blink, fine. If it doesn't, I will not use my time, waste my time. But it does take a blink. And I do get x equals -10, and I do get x equals 2. If it takes longer than a blink, I will use the quadratic formula. You know what I mean by a blink. Okay, now I go back to the original problem, which was 20 minus 8x equals x. And when I plug in 2, I'll say -8 times 2 is -16, 20 minus 16 is 4, the square root of 4 is 2. Yes, it is. But I wouldn't even dare to plug in -10. Well, let's say we forgot. And let's plug in -10. So positive 80 plus 20 is 100. The square root of 100 is never -10. So it turns out that this was an extraneous solution. Not acceptable. It doesn't work in the original problem. It's a byproduct of squaring. Yes, algebraically it's correct, but it doesn't make any sense in the problem I'm trying to solve. And this is the method of solving quadratic radical equations. And I like to look at least at one more. Let's say 18. Let's stop for a moment and see if you have any questions. Any question?
Nope.
Everything okay? Can you follow? Please don't fall behind. If you feel like it's rushed, I know in this class it's always rushed, but stop me if you need more time or you have a question.
I think it makes sense.
Okay, so look at this equation. It has one radical, but it's not a clean situation like this one, where I had the radical isolated on one side and everything else on the other. So I have to perform some steps before I consider it cleaned up and ready to go. So what do you think we should do?
I think we should add the square root of x plus 11 to the other side.
Excellent. That's the idea. Isolate the radical. Isolate the radical. Absolutely. Great job. So when I move one, it's positive, it will become negative. When I move the radical that has minus in front, I'll move it to the other side, it's positive. So x minus 1 equals the square root of x plus 11. Finally, I want to remove this symbol from the top of x plus 11. How do I do that?
You raise the sides to the power of 2.
Excellent. Keeping in mind that I have to check. Why do I have to check? Because I use the procedure that may create false solutions, may create a byproduct that I don't need. It's a waste. Good. So I'm going to put the right-hand side as what?
X plus 11.
Great job. And now please be very careful. I promised you that I'll bring this to class, so to our presentation every time, every class. So please tell me what to write on the left-hand side and how many terms. Good, I'm ready.
Go ahead. Somebody else is speaking.
X squared minus 2x plus 1.
Great job, excellent, very good. Thank you. You make me very proud because this is crucial. This is the basic of everything here. Great job, thank you. Good, now I know what to do. I move everything to one side. It's quadratic, minus 3x, and then minus 11. This is the equation I have to solve now. If factoring takes a blink, fine. Completing the square, never. Taking square roots, I can't. So it's between factoring, if it's a blink, and quadratic formula. And it is a blink. Can anyone give us the factored form in a blink?
X minus 5. X plus 3.
Excellent job. So we have x equals 5 and x equals negative 2. Perfect. Of course, remember they come with a big question mark. I have no idea whether I got correct solutions or the equation has any solutions. I have not checked yet. I copy the original problem with no changes, no simplifications, nothing. So I plug in 5. 5 plus 11 is 16. The square root of 16 is 4. 5 minus 4 is 1. I'll say yes. Now I will plug in negative 2. Negative 2 plus 11 is 9. The square root of 9 is 3. Negative 2 minus 3 will never be 1. And I will say negative 2 is not possible.